Hello, welcome back to my channel. Myself Vishwajit. I have completed my masters from IIT Dhanbad. So, I have completed up to question number 60 in part 1 and 2 for CPET 2024 question. So, in this video, I am going to discuss the last 20 questions. So, first question 61 number. The resolving power of a telescope for light of wavelength lambda is proportional to. So, if we know the resolving power formula equal to D by 1.22 into lambda, where D is the diameter of objective lens. Diameter of objective lens. Meter of objective lens. So, from here we can see that resolving power is inversely proportional to lambda. So, which is option D. So, next question you are. So, next question कहला 61. So, 61 कहला 62. The kinetic energy of a particle moving with the relativistic speed equal to its rest energy. Okay, so here we have to solve this question. So I open this page. So first is relativistic kinetic energy is given by kinetic energy equal to gamma minus 1 into m naught c square, where gamma is constant whose value is 1 by 1 minus b square by c square root over. So it is the relativistic correction made by Albert Einstein. So it is saying that this kinetic energy is equal to the rest mass energy of the particle. So rest mass energy, first we have to write rest energy. So rest energy is equal to m naught c square, where m naught is the rest mass of an object. So according to question, we have to make both the equation equal. So according to question, so kinetic energy is equal to rest energy. Okay. So gamma minus 1 whole into m naught c square is equal to m naught c square. So if I multiply this one, it will become gamma into m naught c square minus m naught c square is equal to m naught c square. So this take into this side, so it will become like gamma into m naught c square is equal to 2 into m naught c square. So m naught c square both sides get cancelled out. If I put all the values of gamma, it will be 1 minus 1 by b square by c square root over is equal to 2. So now I can write 1 minus b square by c square root over is equal to 1 by 2. So I just take its reverse. So 1 minus b square by c square, just I take its root over by taking square on both the side, it will become 1 by 4. So now b square by c square equal become 1 minus 1 by 4. So 1 by 4, which is 3 by 4. So if I take b is equal to, it's a root 3 by 2 into c. So if I check in the option, it's root 3 by 2 into c. So this one, the ratio of speed of particle to the light. That means where we get v square by c square is equal to root 3 by 4. So v by c equal to root 3 by 2. So this is on the ratio. Okay, yeah, next question. So next question kahila 63 number question. A plane unpolarized monochromatic electromagnetic wave is incident from a dielectric medium index 1 refractive index n2 at an angle theta. So the reflected electromagnetic wave is completely plane polarized. Then n2 by n1 is equal to. So we have one law that we call Baerster law. So according to that, Brewster law telling that tan that Baerster angle theta b equal to n2 by n1. So if I compare N2 by N1, so it will be tan theta. So because your angle is theta, so it's option D. So your next question go. So next question is 65 number. So 65 number is saying a superconductor behaves like. So superconductor 64. So it is saying that a superconductor behaves like, it's the option number A, which is perfect conductor and diamagnetic material. So if you look, it's 64. Its answer is perfect conductor, or we can say perfect diamagnetic material. Clear? Then next question. So next question is saying 65, a ideal fermionic system at absolute zero temperature, if n is the density, so fermion of energy, so how it is related? So you have to find its relation. So according, if you know the formula, so formula is saying that fermion energy is equal to its h squared square by 2m whole into its 2 3 pi square n 3 pi square n to the power 2 by 3. So it is saying that we have to related where n is the number density of fermion. So where it is this one. So if I write EF is directly proportional to n to the power 2 by 3. So which is option B. So 65 option B. So next question jiba 66. So our next question is this one. So it is saying that which of the following is doubly magic nucleus? So first, what is the magic numbers? So magic numbers are 2, 8, 2, 8, 20, 28, 50, 82, 126. So these numbers are, we have to remember, are called as magic number. So we have to find its carbon. Its atomic number is 6. So it has proton number is 6 and neutron equal to. So mass number is 14. So mass number will become 8. So it is not doubly magic. It's only one magic number. So it will not be our answers. So next is cobalt. Cobalt is, its atomic number is 27. So that means proton or electron is 27 and a neutron number is 60 minus 27, which is 33. So as these are not anywhere, so this is not a magic number. Then our helium atomic number is 2, so proton equal to 2 and neutron equal to 1. So it is also not a magic number. But oxygen, its proton equal to 8 and neutron equal to 8. So it both are a magic number. So our answer is B, which is doubly magic number. Okay, next question जो so next question कहिला जे a plane conducting loop having a vector area A carries a steady current I and is placed in an external uniform magnetic field B. So the torque on the, okay, so as we know, so torque formula tau is equal to mu cross B, where mu is the magnetic moment. Mu is magnetic moment. So whose value is, so mu is equal to I into A. So A is the area vector. If I put in the place of here, so tau or torque will become it's I into A into B. So it will be I into A. It's option B. So correct answer is option B. So next question jiva. So next question is saying, question number 68 is saying a gas enclosed in a given volume in thermal equilibrium, if the gas are assumed to be spherical in diameter d, so mean free path molecules is proportional to how mean free path is proportional to diatomic. So we have to write its formula first. So mean free path lambda is equal to 1 by root 2 pi n pi d square, n pi d square. So if you look from the formula, so its lambda is inversely proportional to square of d. So which is option number C. So mean free path is inversely proportional to diameter d. Sorry, square of inversely proportional to diameter d. Then next question 69 is asking which of the following Boolean relation is not obey De Morgan's theorem. So first, what is De Morgan's theorem? De Morgan's given two theorem. First one is A plus B whole dash is equal to A dash into B dash. And the second one is A dot B whole dash is equal to A dash plus B dash. So if I show these are this one the second one rule and this one the first rule, so these two are obeying. So we have to thought which one is not obeying. So the if I look into the C, I will mark so A dot B dash dash whole dash. So according to this formula number 2, it will be become like A dash plus B. Already there is one dash, another dash. So there is one rule Boolean algebra. If double dash will become simply B. So I can write it as A dash plus simple B. So it is obeying C. So that means this one is the our answer, which is not obeying the Boolean algebra. So 69 answer is option B. So 69 answer option B. Clear? So these three are obeying the Boolean algebra. This is not obeying the Boolean algebra. So this is our answer. So next question, question number 70. 70 is saying a plane polarized electromagnetic wave is incident normally a quarter wave plate. So when it is going through a quarter wave plate, its phase difference is phase difference which is pi by 2 or 90 degree. Okay. Then electric field making an angle 45 degree with the optic axis of quarter wave. Okay, then electromagnetic wave emerging of the quarter wave plate is. So when it is going through a quarter wave plate, it produces a phase difference of pi by 2. So as it is produce a phase difference pi by 2, and this one making an angle 45 degree with the optic axis of quarter wave, it indicates that amplitude of two orthogonal components are equal. It indicates amplitude of two orthogonal components are equal. That is E1 equal to E2. So if E1 equal to E2 and its phase difference equal to pi by 2, which indicates that it did produce a circular polarized wave. So answer 670 number option C. So next question jiva 71. 71 is saying, so question is how the energy density is varying with frequency and V and temperature. So this is the option. So according to Rayleigh-Jean's law, so you have to first write its law. So law is saying its density U is equal to 8 pi frequency square by CQ, where C is the speed of light, into KT. So from here, if I write directly, mu is directly proportional to frequency into T. So which is option A. So option A is the correct answer. So next question 72. So 72 is asking the primary process of energy production in stars. So always in stars and moons, energy will produce in the process of nuclear fusion. So there is a carbon-carbon cycle is going on, which always produce carbon-carbon circular cycle is going on, will produce lots of energy and light. So next question jiva. So two conducting loops are placed close to each other when electric field of one it changes at the rate of 1.5 per ampere per second. That means it is saying that di by dt is given as 1.5 ampere per second. Okay, and another is EMF is given. EMF is given that 0.3. So it is asking mutual inductance. So mutual inductance formula equal to E is equal to M di by dt. So if I put all these values, it will be like 0.3 is equal to M into 1.5. So it is, if I solve, M is equal to 0.3 divided by 1.5. So if I solve it, it will be like 0.2. So it is important to remember its unit. To find out its unit is Henry. So 0.2 Henry, which is option C. 73, option C, 0.2 Henry. So next question, the temperature at which Joule Thomson coefficient changes its sign is called, it's directly you have to remember, it is called as temperature inversion. Okay, next question, Jiva. So it is saying that a monochromatic plane polarized light passes through a optical active medium of light L. The angle through which a plane polarized of light is rotated is proportional to. So you have to also remember this one is directly proportional to L. So 75, option A. So next question, Jua. In the low frequency of light, Planck's formula for black body radiation leads to. So it is also known as this one. That option D, which is Rayleigh-Jean's law. That same as black body radiation. So that which we discussed in this question, the above question, this one also useful for black body radiation. This one is our energy density, how much energy is radiated from a black body. So same answer, same question. Okay, the next question, the ratio of half life to the mean life. So half life T half formula is 0.693 divided by lambda. Again, mean life T mean equal to which is 1 by lambda. So in place of 1 by lambda, if I put this one, so by, or divide this one, I'll get directly T half divided by T mean equal to 0.693. So which is option A. 77, option A. So the next question, 78. It is saying that the magnetic susceptibility of a material of very small negative quantity. If small negative quantity susceptibility, then its answer is diamagnetic material. Because for paramagnetic material, its susceptibility is slightly positive. For ferromagnetic, it's a highly positive. For this one, it's negative. So thus it is not a magnetic material, it has no susceptibility. So this one is wrong. So 78, option B. So the next question, 79. So 79 is N represents a whole concentration of semiconductor, then Hall coefficient. So as we know, Hall coefficient formula RH is equal to 1 by N into Q. So from here we can just write that RH is inversely proportional to 1 by N. So 1 by N. So it is not matching with the options. So let me check once again. So next question, Jiva. Question number 8. The exchange of both energy and number of particles with the surrounding. So the surrounding which is possible. So it is both energy and number of particles is only exchange in case of grand canonical ensembles. Okay, so but I can write for canonical microcanonical ensembles, there is nothing will be allowed. That is no energy or particle is allowed to exchange. But in canonical ensembles, they allow only energy. Allow energy, but not particles. Not. But in canonical ensemble, grand canonical ensembles, they allow both energy and particle. Energy and particle. So I think question number 79 is there is some mistakes. So I'll stop here my video, and the next video I will. So in the next video, I'll discuss the more questions. So it is also helpful for both for LTR and also helpful for CPET 2020, the 2025. Thank you for watching. If this video is really helpful, like this video. Thank you. Thank you a lot.